Welcome back, dear students, to the physics vision classes. The given question is, we have given a partial differential equation which is actually wave equation, okay, and certain boundary conditions like at x is equal to 0 what is its value, at x is equal to L second boundary what is its value, similarly at t is equal to 0 and derivative of this function at t is equal to 0. These boundary conditions are given to us in the given question. What we need to do, we just need to find out that function u which satisfies all these equations or all these conditions. Okay, we'll make use of one trick in this. What is trick? Trick is, or shortcut you can say, it's a very lengthy question to solve the exact differential equation, partial differential equation, that is wave equation actually, and satisfy all these boundary conditions. So we'll make use of the given options and see it by symmetry. Along with that, we'll go with the non-zero boundary conditions. Non-zero boundary conditions. We will check which option satisfies the boundary conditions. Particularly, we are interested in those boundary conditions which are non-zero, means which give the values equal to values not equal to 0, like this or this. Okay, so this is the part, this is the way we'll do this question. Okay, so let's try to understand it in a simple manner and try to do it immediately. So what we'll do, we'll first check the boundary condition, like let's say this. At t is equal to 0, at t is equal to 0, we have the value of u as sin pi x by L. Now check the condition with the first condition. At t is equal to 0, this factor is gone, okay, because this is 1. So we are left out with sin pi x by L, and this factor is also gone, so we are left out with this factor. But this plus this is not equal to sin pi x by L. Therefore we can say option A, you can cross verify this thing, okay. Therefore we can say option A is definitely wrong, okay. In rest of the conditions, this condition, boundary condition, is rest of the options satisfy this boundary condition. So one option is cancelled out. Let's go for the second option. There is no symmetry in x and t here. Here we have the coefficient of t as 2 pi by L, and here the coefficient is pi by L, okay. Similarly in option C, here we have the coefficient as 2 pi by L, but coefficient of t is pi by L only. So these two equations does not satisfy the condition of symmetry in x and t, because in wave equation x and t should be on the same footing, okay. Moreover, you can also cross check this condition by taking its derivative and putting t equal to 0 in that, whether we will be getting this factor or not, okay. So you can cross verify this thing. Let's have a look on this part as well. So if we'll take the derivative of option B, derivative in option B, what will we see? We'll see derivative, we need to take it with respect to t. So this will give us sine, okay, and this will give us sine, and sine 0 is 0. So both the terms will be 0. That is, option B cannot be correct. In the next part, this will become sine and this will become cos. So coefficient of this part will be the correct answer, correct factor which we are left out with, and in the similarly in the fourth option, okay. So this also cancels out one option for sure, but we can check it out with the symmetry, and we got our option as D, which is the correct answer to this question. Okay, so such questions which are quite lengthy or quite difficult can be solved using these kinds of techniques, using the basic understanding of the question, of the physical problem involved. For example, the symmetry problem in this, or a shortcut can be made like just by putting the options, satisfying or ruling out the options by cross checking them with the given question. Okay, so this is the way, and stay tuned with us for more such doubts or questions or solutions or shortcut techniques, and thanks for watching this video.